Yes. You have the floor. Yeah. Thanks for coming. I'm Shuai, and this is my research topic. I'm very happy here to share this with you. Yeah, combine knowledge graph reasoning with large language model. This is the agent. First, I will introduce the background about the knowledge graph, and then I will share one of my work published at ACL 2025, and then I will briefly talk about what I'm doing now. Yeah. So what is knowledge graph? So if we search terms in Google, and we can find that in the right part there is a knowledge panel. And so if this is a knowledge panel, and this the data source comes from the Google's knowledge graph, and we can see knowledge graph is a structured representation. It contains a node and edges. Here, the node is the instance and represents the entities, and the edge represents the relations between the node. For example, here, the Chalmers, the address is in Gothenburg, and it is founded in 1829. So it's very clear to represent some information. Nowadays, a large language model is used everywhere, but but comparing with only using large language model, there are a lot of advantages by utilizing of the knowledge graph. First, the knowledge stored in the knowledge graph is structured. It's clearly explicit. So we know what kind of knowledge is stored in the knowledge graph. But for a large language model, it is stored knowledge in the in its parameters. So we don't know what kind of knowledge it has. And the second, using knowledge graph is we can get some explainable result. Reasoning on knowledge graphs is transparent. We can see the process, but the LLM is a black box. And third, knowledge graph is reliable since the knowledge inside is carefully created and validated. But LLMs will have some hallucination issue. And the last, it's very easy to update the knowledge in the knowledge graph. We just add some nodes and edges to the existing knowledge graphs. But for the large language model, we have to refresh all the parameters. So it's a high cost process to update the knowledge. Yeah. Based on that, it's necessary in some tasks to combine knowledge graphs with the LLMs. This is a very trivial, directly way to let the RAG to make use of the knowledge graph. When we retrieval the information and knowledge graph, and then the second step concatenate the information, retrieve the information with query, and then send them to the LLM to answer the given question. But such way can't make full use of the relation in the knowledge graph. This is a common way to make use of the knowledge graph. That is reasoning on the knowledge graph step by step. Here is an example. Who starred the fuse for the screenwrite of the rear window? And we start from the entity here, the rear window, and we find that that is read by two guys, and then we find that they have read another book, and that is acted by some actors. And then finally, in this way, we can find the final result on the knowledge graph. Um, for comparison, given a knowledge intensive question, we have several ways to study it. First, if we use LLM directly answer such question, that maybe it doesn't have the specific knowledge. Uh, and then if we directly retrieve the information from the knowledge graph, like use the Sparkle query and then answer the question. This way we don't make full use of the LLM to explore the knowledge graph. So nowadays, a lot of research is using this way to combine knowledge graph with LLM, and that is reasoning on the knowledge graph step by step. Here is the example of what is the majority party now in the country where Canberra is located. So first, look at the first entity and then camera and then think uh, to find the next entity, the capital of Canberra in Australia, and then think the next step. They search a lot of entities and select the most related one here. Yeah, this one the prime minister is Anthony, and then search next and think the leader find the Anthony the leader of Labour Party. So we can answer the question here. Yeah. In this paradigm, we can see there are at least three advantages. First, starting paradigm facilitates the standardistic inference between LLMs and KGs, and this process is explainable. We can clearly see the inference process. And this process, we don't require any training or fine tuning. So it's very easy to use to combine the knowledge graphs with LLM. But here are also some limitations. Here are two examples. First, I find sometimes it's difficult to discover effect reasoning passes, especially for the reasoning pass is very long. Here is an example. What is the official law of the affected area of the cyclone tropical storm Fabio? And we use the same process. First, we find the topic entity and we find that such storm affected the two areas. But here in this step, it is confused. Where should we go next, and Hawaii or Pacific? And in this step, it doesn't find any related entities, but in the upper one, we find Mexico is nearby the Pacific. So here, the LLM will give the wrong sum. The Mexico's national flower is the dahlia. But in our view, yeah, what we want is we want to know is the official flower of Hawaii. So here, yeah, in my opinion, the reason is the multi of reasoning may cause the LLM's attention to drift, so relaxing to focus on the problem solving. So yeah, this may cause some errors. And secondly, there is a prematurely discarding critical multiple connections. For example, why compose the soundtrack? Who composed the soundtrack for the Harry Potter movies? And we also again we find the topic entity in knowledge graph and search the one home neighbor. We find that this is not contributed to the original question, but the two home neighbors is the answer. So yeah, how can we find a two hop related information in the knowledge graph is also an issue. And in my opinion, yeah, the existing methods don't utilize the contextual information of anything. For example, Harry Potter movies also conclude the context. That means the one home neighbor. Based on these considerations, I propose one method to solve this and such method is published in the ACL 2025. To solve the first limitation, the difficulty in discovering effective reasoning, capacity multiple reasoning process. I have an idea to think about how humans keep their attention on a multiple question. And I find that one way is to keep asking them questions and ask them to answer. And I just try this. So here I design a method to guide the LLM iteratively asking simpler sub-questions and to maintain a clear reasoning path. To solve the secondary issue, to make use of the context information to avoid the prematurely discarding multiple connections. Here I adopt gene graph neural network to incorporate the second hop semantic info to help the model look ahead and preserve the key connections. Here is the framework of our method. We can see the first. We can see there are also several steps here, and the first row is the reasoning process of our method, and and the second row is our device the module. And the third row is how we select the knowledge graphs. And give a question and what is the official flower of the fact area of the storm. And we first find the entities here, and then here we generate a sub question using a large language model. First, we have to figure out which was affected by the storm. And according to this question, we find the related the one hop neighbor in the knowledge graph, and we select the related node according to this sub question and we try. In this step, our goal is to answer this sub question. And here we use another LLM answer. The one of the answer is Hawaii, and based on this answer, we do this process again to generate the next question. What is the official flower of Hawaii? And then we select again. We find the here we find that in the knowledge graph it doesn't compute such information, but sometimes the LLMs will have the information. So they answer such several questions based on its own knowledge, and then get the final answer here. So let's see. Yes.
What happens if you have negations in there? So, what if the question has been, what is the official flower of the effect of the areas not affected by a tropical storm? I know it's a nonsense question, but what if you throw that in? The knowledge graph can look for not.
Not.
Yeah, not.
Have to think about it. So you mean there is not there are some not.
Yeah, there's some negation. Yeah, I'm looking for things that are not affected by this.
Oh.
Or give me countries that are not affected by this. Give me an Asian country not affected by the storm.
Oh yeah. Sometimes if they retrieve the false knowledge, the answer will be false.
Yeah, is the knowledge graph closed under negation? If you have a relation, do you also have the negation of the complement of the relation?
Yes.
Is parent is not parent?
Yeah, both.
No,
No, they don't. This will blow up.
negation as failure or something like that. So,
But you should be able to search for stuff like that using the Sparkle query language.
yeah,
It will take longer to respond, right? Because if you search for like what is not or which flowers are not the official language, the official flower, then you will have a lot more results.
Yeah.
Right.
But this is still not submission, it's negation by failure.
Yeah.
Well,
Yeah.
yeah, curious about it.
the Sparkle has this
Yeah.
the graph itself. Yeah, doesn't have.
Yeah, it's an interesting view. Yeah, I haven't thought about that. It's I don't know in this logic.
I have another question. Maybe I missed an explanation. So you have this compressed question in the beginning.
Yes.
The user.
Yeah.
Then you split it into sub questions. But who does the splitting? Is it do you ask the LLM now making it two questions? So
Yeah. I asked the LM to decompose the
Okay.
question.
so if the LLM doesn't do the splitting right, then the result is still wrong.
Yes. Yeah. I will go talk about each module in detail.
Okay.
Here is how now I will talk about this module, how it generated some questions. Here, I use one LLM. The input is original question and some context. Here is the context is a sequence. The previous question and the previous answer is a sequence. And that means I put all of the historical information here with the original question and to ask LLM think what kind of status what we are, and the next question what it should be, and then generate it. So I in this paradigm I want to ensure that the reasoning stays on track step by step. So it's looks like a prompt engineering in this step. Yes. And here I to retrieval neighbors of one entity. Yeah, I use Sparkle template. Yeah, for example, find movies directed by Christopher what I want me to do is to use this simple Sparkle query, and this is the previous ID in for the Christopher, and we can find we can also find the relation in the freebase. So so here in this way we can retrieve the one home neighbor here, and to aggregate the more context information that I use GNN. Here is how it works. We aggregate all the one home neighbor and also as well as its own self. We use GNN to update its representations. And after that, we want to select the entities related to the sub question. So after that, I concatenate the sub questions and this representation, and then passed by two-layer MLP. And finally, we can got a score here in the range 0 and 1. Then we select the top case highest score as the related one. Yeah. And this gene I directly use the graph SAGE to aggregate the information here. And here, we can see the result. We we do the we perform the experiment on two kind of data set. One is multi-hop reasoning, and the other is generalization. And we here are four benchmarks. We can achieve the best or the second best on these four data sets. Here are some detailed analysis. First, compared with the first two line results, we can see that with or without KG. If we utilize KG, this is use KG like a RAG. We can significantly improve the result. So you can see the additional specific knowledge is very important here. And we also use different LLM to generate sub questions. Here we can see, the stronger model can generate can decompose the question better. So here, but we also can see even use a very small model, it also works. So here we can conclude that generate the question and using question to guide the reasoning process really works. And we can, and the can also see the GNN also improves performance a lot. Yes, this is the first work.
Sorry,
Yes.
could you explain some of the columns on the table? I don't know how to read them.
Some columns.
I don't understand how to read the table. Oh, explain.
Yeah.
What do you mean?
The matrix is pass at 1. And the number, the larger number, the better. And here are 1, 2, 3. Here are 4 different data sets. The CWQ is the most difficult one. And they are also this have the question here have very long reasoning chain, and this is the easy one. And
So these are benchmarks?
these are benchmarks.
Okay.
They are based on the free base. The free base knowledge graph is built by Google. It's a
Okay, so this is just the performance of your tool, not a comparison with other tools.
No, here no. But here the table I compare with several existing methods here. And so we can. I compare with all these LLM based method. We can see we can achieve very good result here. Yes. So then I will introduce what I'm doing now. This year large reasoning model is very popular. Like DeepSeek. So what is large reasoning model? That is think before responding to solve reasoning problems. Here is an example. This is math physical question, and they before solving it, they think and then answer. And here we can see from the result, the first 4 columns are LRM, and the last column is LLM. You can see in the math and code tasks, the LRM is better. So based on this, I just think about I use the LRM to solve my to help my task to enhance the knowledge graph reasoning. And this is the upper part is my existing work. The upper part is previous work, yeah, the step-by-step reasoning, and here is I'm working on now in my framework. Here I just want to integrate the several individual reasoning steps into one LLM code. How can I achieve this? I find that if I generate the search tokens I can code the search tool and then get the search result with the search retrievals, and then after that it can also also continuously thinking about the previous result, and in this process we can search many times, and so in such paradigm we can perform the multiple reasoning in one LLM run. So yeah, and after thinking, yeah, we can get the answer. So yeah, such process is very concise, and yeah, we don't need to define the reasoning paradigm. So it's more flexible, and there are a lot of merits here. Yeah, I'm fine now. Yeah, and let's see some initial results, and here. The last two lines are my existing result. We can see it's very promising, so compared with the other method. And I also use the reinforcement learning to train the model. Yeah, I compare with reinforcement learning or supervised fine tune, and I find the reinforcement learning can achieve better results. The reason is I think the reinforcement learning can enforce a model to explore better, and in this process, LLMs can learn how to explore. I mean, such reasoning process. Even for the DeepSeek, yeah, or the existing large reasoning model, they always use reinforcement learning to learn to enforce LLM learn how to read the process. So here, yeah, I also use such training technique to enhance our performance. Yeah. So that's it all. Thank you. Any questions?
We have half an hour for questions.
Yeah.
Thanks for a great talk. So the very first formulation of this problem, it actually resembles the project that we have with Krasimir and some others about the abstract Wikipedia, where you have the Wikipedia. I mean, you have Wikidata, which is a knowledge graph. I think it contains all of Google's knowledge graph and much more. And the task is to generate articles, Wikipedia articles from that knowledge. And the reason is that people hallucinate when they write Wikipedia articles. So that's one reason. Well, not hallucinate in the same way, but in order to keep the articles up to date, that's one thing. If something changes, and then also to generate all of the different languages from the same data. So this could conceivably be done in a similar method, so that instead of asking a question, the question is like, write an article about Mexico or something like that.
Oh, yeah.
And so it would, then you would somehow split it up to different questions, like what is the capital of Mexico, or how would you apply? Do you see a connection to?
I got it. Yeah, there are. That is another task in knowledge graph.
Yes.
So they generate the full articles according to the structure, the graph structure.
Yes.
Yeah, in my opinion, they try to combine the triples, the subject, as the subject, verb, and objective. Yeah, they can they concat them and then send them to the LLM and generate the natural language and then and then combine the several sentence to the final article. Yeah, that is what they are doing now.
How do they select what information to show?
Mhm.
How do they select what information to show?
Oh, select what information. Yeah, they maybe I think they also use such ways, to explore information on the knowledge graph. The same, I think uh, this is the same way to select.
Okay,
step by step. Yeah, they can. I think they can also use my method, to in each step just ask several questions, to help for selecting the information.
So the most relevant one is has to be applied many times. So how did you tell us how you decide what is the most relevant?
Oh, the most here are many methods. Yeah, we can use just like me, where I use two layer neural network. It is like we can also use the semantic matching, or even use another LLM to select one. Here are several neighbors. Yeah, and we can put all the neighbors and the original question into LLM and ask the LLM itself to select the related entities. And,
So that means that you can you get something which is not completely reliable, but it can be.
yeah.
And it's explainable. It's at least it's explainable, so they can refer back to the knowledge graph.
Yes. And here we can also use a technique here, to like EM25 and the semantic matching, to select them. We calculated the semantic of these nodes with the original question, and we can calculate a similarity score. Yeah, and then select the highest score.
Question in the back?
Yes.
Another way of going would be to take the knowledge graph and use it to generate synthetic training data.
Yeah.
Take an LLM and generate huge amounts of training data on that. How does that compare? I mean, I know you don't get any, you can't explain it then, but how's the results turn out?
I know there are a lot of research. They want to inject knowledge from knowledge graph in that way. Generate the document from knowledge graph and then train it. Yeah, it can also get very good results, but but this but it's very it's not easy to update the knowledge, So we want to add, for example, add some news or change some knowledge. So it's not easy.
I was more curious what if I did it with a fixed knowledge graph and did that, how did the result of that turn out to be compared to do what you're doing?
Like the RAG method is better. I tried that just fine tune all the knowledge here, and then to answer a knowledge intensive question, and then compare with just RAG retrieval knowledge for the knowledge graph. The retrieval is better. This is more explicit and directive. Yes. Yeah.
Any more questions?
So you gave a GitHub address at one of the.
Oh yeah,
So
yes.
what does it? I mean, if we would like to try out something like this, so what else would we need? Then your code, of course, it is described there, but just do we need a cluster, for instance?
Yeah, you need a very large storage and to store the Wikipedia and all the Wikidata. Yeah, at least 600 G. Yeah, 600 G gigabyte. Yes, yes, it's very large. Yeah.
Wikidata is not so big.
Huh? Sorry.
Wikidata is not so big. I have several copies.
Mhm.
But do you uncompress it or?
Yeah, I store. Yeah, I store it in the database. Yeah, and I have
Okay,
process.
yes.
Yes.
If there are no more questions, we can thank the speaker again.